Mount Redoubt, a towering stratovolcano in southern Alaska, stood silent for over 20 years before showing signs of an awakening in late 1989. Nestled within the Aleutian Range, this massive volcano had a history of eruptions, but its long dormancy had lulled many into a sense of security. However, beneath its seemingly tranquil exterior, forces were building that would soon make headlines across the globe. In the months leading up to the eruption, subtle shifts in the volcano's behavior caught the attention of scientists. Small but persistent earthquakes rippled through the ground, a telltale sign of magma movement deep within the earth. The frequency and intensity of these tremors gradually increased, hinting that Mount Redoubt was preparing for something significant. Steam emissions from the summit vents became more frequent, and the surrounding glaciers began to show signs of melting. The United States Geological Survey, USGS, closely monitored these changes, piecing together the clues of the impending eruption. At that time, volcanic monitoring technology was not as advanced as it is today. Instruments like seismometers and tilt meters provided critical data, but they were limited in their ability to predict the exact timing or magnitude of an eruption. This uncertainty left scientists and local residents alike in a state of constant vigilance, waiting for the inevitable. The region around Mount Redoubt, known for its rugged beauty, was home to scattered communities, small towns, and vital infrastructure. The nearby Drift River Terminal, a facility used for storing and shipping crude oil, was a major concern. Its proximity to the volcano made it highly vulnerable to the potential hazards of an eruption, such as ashfall, lahars, and pyroclastic flows. Preparations to mitigate risks were underway, but no one could predict the scale of what was to come. By early December of 1989, the seismic activity had reached a fever pitch. Earthquakes were now occurring in rapid succession, and steam plumes rose ominously from the summit. The USGS issued alerts warning of a likely eruption. Local authorities coordinated emergency plans, and residents prepared for the worst, stocking up on supplies and making evacuation plans. Despite these efforts, the sense of unease lingered. As the days ticked by, tension grew. The world turned its eyes to Alaska, captivated by the dramatic buildup of one of nature's most powerful forces. Scientists worked tirelessly to decipher the signals coming from Mount Redoubt, knowing they were witnessing a prelude to a significant geological event. The stage was set, and the volcano's long slumber was about to end in spectacular fashion. On December 14, 1989, Mount Redoubt ended its years of dormancy with a sudden and dramatic eruption. It began with a powerful explosion that sent a towering column of ash and gas spiraling nearly 10 miles into the atmosphere. This was the first in a series of eruptions that would last for months, each more unpredictable than the last. The initial eruption coated the nearby landscape in a thick layer of volcanic ash, turning daylight into a dim, gray haze. For the people living in the surrounding areas, this marked the start of a challenging and chaotic period. The ash cloud, propelled by strong winds, spread far beyond the volcano, affecting communities hundreds of miles away. Air travel, a lifeline in Alaska's vast and often remote regions, came to a standstill. Anchorage, the state's largest city, saw its airport operations severely disrupted as ash particles posed a serious threat to aircraft engines. Flights were grounded or rerouted, and travelers were left stranded. Pilots navigating the airspace faced the daunting task of avoiding the massive ash plume, which could cause catastrophic engine failure if encountered. The eruption also unleashed another dangerous phenomenon, lahars. These fast-moving torrents of volcanic mud and debris formed as the heat from this eruption melted the glaciers and snow on Mount Redoubt's summit. The lahars surged down the mountain's flanks, carving paths of destruction through valleys and waterways. One of the most notable impacts was at the Drift River Terminal, where crude oil tanks were directly in the path of these devastating flows. Emergency crews worked around the clock to protect the facility, building berms and pumping out oil to prevent a potential environmental disaster. For weeks, Mount Redoubt continued to erupt intermittently, with each event bringing new challenges. Volcanologists documented pyroclastic flows, searing avalanches of hot gas and rock that raced down the mountain at incredible speeds, obliterating everything in their path. These flows not only reshaped the terrain, but also created significant hazards for those attempting to study or manage the eruption's effects. The ongoing eruption forced many residents to evacuate their homes, leaving behind their belongings and livelihoods. Schools and businesses closed, and communities struggled to adapt to the new reality of living under the shadow of an active volcano. Emergency shelters were set up, and local governments coordinated efforts to distribute clean water and medical supplies to those in need. The ashfall contaminated water supplies, clogged machinery, and created respiratory issues, particularly for children, the elderly, and those with pre-existing health conditions. Scientists working on the ground faced immense challenges as well. The conditions were harsh, with ashfall reducing visibility to mere feet and coating their equipment in fine abrasive dust. Despite these difficulties, their efforts to monitor and study Mount Redoubt provided critical information that helped guide emergency responses and protect lives. As the eruptions continued into early 1990, it became clear that this was no ordinary volcanic event. The sheer scale and intensity of Mount Redoubt's activity captured the world's attention, highlighting both the destructive power of nature and the resilience of the communities affected. As Mount Redoubt's eruptions intensified in early 1990, the volcano unleashed some of its most powerful and dramatic displays. The ash plumes grew larger, frequently reaching altitudes of over 40,000 feet, and disrupted air travel, not just within Alaska, but across significant portions of North America. The fine volcanic ash particles carried by the wind spread as far as parts of the lower 48 states and Canada, creating a widespread environmental and logistical challenge. One of the most significant hazards during this period was the impact on aviation. Volcanic ash is notorious for its ability to cause severe damage to aircraft engines, potentially leading to in-flight engine failure. A particularly harrowing incident occurred in December 1989 when a KLM Royal Dutch Airlines flight encountered the ash cloud. The Boeing 747's engines all failed mid-flight, leaving the massive jetliner in a dangerous glide. Miraculously, after multiple attempts, the pilots managed to restart the engines, narrowly avoiding disaster. This close call underscored the critical need for real-time volcanic monitoring and prompted aviation authorities to establish better protocols for volcanic ash avoidance. Back on the ground, the lahars continued to wreak havoc. As the eruptions melted the extensive glacial ice atop Mount Redoubt, these destructive mudflows grew in size and frequency, cutting through valleys and river systems. They repeatedly threatened infrastructure like the Drift River oil terminal, where protective measures were constantly tested. Engineers and emergency crews worked tirelessly to reinforce barriers and divert flows, preventing catastrophic damage to the facility and potential oil spills into nearby ecosystems. The Drift River evacuation and safeguarding efforts became a symbol of the complex interplay between human activity and natural disasters in Alaska's rugged environment. The surrounding communities faced ongoing hardships as the eruptions dragged on. Ashfall remained a persistent problem, blanketing towns and causing widespread damage to machinery, vehicles, and buildings. The abrasive ash clogged air filters, corroded surfaces, and created long-term maintenance challenges for equipment critical to daily life in Alaska's remote regions. Residents had to wear masks and goggles to protect themselves from the health risks posed by the fine particles, which could irritate the lungs and eyes. Roads became treacherous as the ash mixed with snow and ice, creating slippery and unpredictable surfaces. In addition to the physical dangers, the eruptions brought significant psychological and economic stress. Families were displaced from their homes for extended periods, businesses suffered losses, and the cost of disaster response and recovery mounted. For many, the constant uncertainty of when the eruptions might cease added to the emotional toll. Local officials worked alongside federal agencies to coordinate relief efforts, ensuring that food, water, and medical supplies reached those most in need. Community resilience was put to the test as people banded together to support one another through the crisis. Meanwhile, scientists continued their meticulous monitoring of Mount Redoubt's activity. Advances in technology allowed volcanologists to gather data in ways that had never been possible during previous eruptions. Instruments measured everything from seismic activity and gas emissions to the rate at which glaciers were melting. The findings not only helped to inform immediate response strategies, but also contributed to the broader understanding of how stratovolcanoes like Mount Redoubt behave. This eruption became a landmark case study in volcanology, with lessons that would inform future monitoring and preparedness efforts around the world. As Mount Redoubt continued to erupt well into the spring of 1990, it became increasingly clear that this event was reshaping both the physical landscape and the lives of those who called the region home. The combination of natural destruction and human determination would leave a lasting legacy in Alaska's history. As the eruptions of Mount Redoubt gradually waned in the summer of 1990, the immediate crisis transitioned into a period of recovery and reflection. The region, once blanketed in layers of ash and scarred by the powerful lahars, began the slow process of healing. For the people who lived through this event, the eruption left not just physical marks on the landscape, but also lasting impacts on their communities, industries, and scientific understanding of volcanoes. In the aftermath, cleanup efforts became a monumental task. Entire towns had to deal with the thick layers of ash that coated homes, streets, and public spaces. Removing the ash required careful coordination as it posed significant risks to both machinery and human health. Crews used heavy equipment to scrape it away while individuals worked tirelessly to restore their properties. Water systems clogged with ash needed extensive repairs, and local governments faced the challenge of funding these efforts while ensuring the safety and well-being of their residents. The long-term environmental effects of the eruption were equally profound. The ash deposits enriched the soil in some areas, boosting plant growth in the years that followed, but they also caused significant disruption to local ecosystems. Rivers and streams choked with volcanic material, altered their courses, and disrupted fish habitats, impacting the vital salmon populations that so many Alaskans relied on for food and income. Wildlife, too, was forced to adapt to the dramatically changed landscape, and some species faced increased challenges in the immediate years after the eruption. Economically, the eruption's consequences were wide-reaching. The aviation and oil industries, both crucial to Alaska's economy, bore the brunt of the disaster. The grounding of flights during the peak of the eruptions caused financial losses for airlines and disrupted travel for thousands of passengers. The Drift River oil terminal, though saved from catastrophic destruction, required extensive repairs and operational adjustments. For many businesses in affected areas, the costs of recovery proved a significant burden. Despite the challenges, the eruption also brought important advancements in volcanic science and disaster preparedness. The data collected during Mount Redoubt's eruption became a cornerstone for understanding how volcanoes interact with glaciers, how ash plumes affect aviation, and how lahars behave in rugged terrains. This information informed future disaster response strategies, not just in Alaska, but globally, as scientists and emergency planners applied these lessons to other volcanic regions. The eruption of Mount Redoubt also highlighted the resilience of Alaskan communities. Faced with one of the most significant volcanic events of the 20th century, people came together to rebuild and support one another. From Anchorage to the small towns near the volcano's base, stories of neighborly assistance and determination emerge as reminders of the human spirit's ability to endure even the most daunting challenges. By the end of 1990, Mount Redoubt had largely quieted, leaving behind a transformed landscape and a wealth of scientific knowledge. While the volcano remains active and continues to be monitored to this day, the events of 1989 and 1990 stand as a testament to the incredible power of nature and the resilience of those who face its wrath. The legacy of Mount Redoubt's eruption lives on, not just in the memories of those who experienced it, but in the advancements it spurred in science, safety, and preparedness. It remains a potent reminder of the unpredictable and awe-inspiring forces that shape our planet, challenging us to learn, adapt, and respect the natural world.